We are continuing with the sample problems from section 11.2, and we have just completed number 18. So we're going to look at the probability of poker hands in number 22. So let me move to a new page here. In 22, it says you are dealt a 5-card hand. This implies without replacement from a standard 52-card deck. Find the probability of getting each of the following. Give your answers to 6 decimal places. And what we're to use is the table 1 from section 11.1. And that is found on page 581. So in 22 we're talking about getting a flush or 3 of a kind. So if we look at this, what we want to do is add up the numbers for a flush, 3 of a kind. So they've counted these for us, that helps. So we have 5108 ways to get a flush, 3 of a kind, 54,912. So I need to add those two. Okay, let's turn it on first and clear it. 54,912 plus our 5108. And I'm coming up with 60,020. Okay, and that's out of, they gave us the total number of poker hands at the bottom of the table, 2,598,960. Okay, so divided by 2,598,960. 0.0230938.529. Let's talk a moment about rounding. Okay, they tell us in this one, give answers to 6 decimal places. So 1, 2, 3, 4, 5, here's 6. 0.02309. To the right is an 8, so we need to add 1 before we drop off the remaining digits. Okay, and let's take a look at number 26. We're given a probability distribution. We have Brian Donahue's probabilities in playing golf for scoring in various ranges on a par 70 course. In a given round, find the probability of each event. So in 26, we want the probability of a 95 or higher. So we would have to add 95 to 99 and 100 or above. So that would be 0.04. Probability greater than or equal to 95. 0.04. We're adding the last two numbers. 28. In the 80s. Okay, there are two that are in the 80s, 80 to 84 and 85 to 89. 80 to 84 is 0.09 plus 85 to 89 is 0.06, and we end up with 0.15. Okay, and we'll do one last one where we construct a probability distribution or a table. Ann Kelly randomly chooses a single ball from the urn shown here, and X represents the color of the ball. Construct a complete probability distribution for the random variable X. Okay, so I'm just going to list the colors rather than drawing the urn. We have, it looks like 1, 2, 3, 4 red, we have 2 blue. I want to run off the page, so I'll go up here. And we have 1, 2, 3, 4, 5 yellow. So that's a total of 11 balls in the urn. So X is representing the color. So blue, red, yellow. So we have 3. And the probability of X is going to be out of the total 11. So it's 2 out of 11, 4 out of 11, and 5 out of 11. And notice the sum of the probabilities is 1, which is correct. Okay, that takes care of the sample problems for section 11.2.